So again, I will put them up at the end of the period. But this is Module 5, Lesson 3, Proportional Relationships. All right. So we have been looking at linear relationships. Okay, so we started out deciding, is this relationship linear or not? That was our first lesson. Is the relationship linear or not? Then lesson 2 was finding the slope. So in lesson 2, we said, okay, well, now we know our relationships are linear. What's the slope? What's the pattern of these lines? Okay. Now, today, we're digging even deeper. We're saying, all right, I know what linear looks like. I know how to find the pattern or the slope. Now, today, we're going to be more specific and we're going to say, okay, now let's figure out what makes a relationship, a linear relationship, what makes it proportional. Okay. Now, proportional means basically that the size of the different parts all fit well together. So if you think about your computer class, okay, depending on what you guys did in computer class, or I mean, honestly, anytime you've done a project on the computer where you needed pictures. So let's say that you're doing a project and you need to add a picture of an apple. Okay, so if you have to add a picture of an apple to a presentation, you go to the internet, you search, and you insert an apple into your slideshow. Okay. Now, the way that this apple came in, it looks a certain way. Okay. Right now, according to this brand new picture I just added, I have a proportional apple. I have a picture of an apple the way it's supposed to be. Now, depending on whether you had a computer class, not, who was your teacher, if you guys did anything like this, or just by trial and error, you've probably learned that if you change the size of the picture using the corner handlebar, the proportions will stay the same. The size of the proportion of the size of the leaf to the size of the apple will stay the same. It's just a smaller version of the bigger apple. It's kind of like if, depending on your class in 6th grade, in your math class, you might have done a scale drawing where you take something small and you make it really big, or take something big and you make it really small, and everything stays proportionate. Same thing is happening here. Now, if you took the handlebar from the bottom and you just dragged up, now my apple is out of proportion. My original apple was kind of tall like this, and by me dragging the bottom, I made it short and chunky. It's not proportionate anymore. All right. So that's kind of what we're talking about when we say proportional. So when we look at our line, it's basically like saying, as I make something smaller or bigger, are the proportions staying intact? Okay, so that's kind of the basics of what proportional means. And as we start going through our different lessons, you'll kind of start seeing how that fits into algebra. So for now, let's get a couple pieces of vocabulary as always. The first piece is proportional relationship. So proportional relationships are relationships where The ratio y over x is constant. So up to this point, we have seen a y over an x. However, it's been change in y over change in x. It has not been y over x. It's been change in y over change in x. So what we have here with the y over x is something a little bit different. What we're talking about is a ratio of the y coordinate over the x coordinate. So for slope, where it was change in y over change in x, we were comparing points. This is just one point. This is the y coordinate and the x coordinate of just one point. We call this k, or the constant of proportionality. Constant of proportionality. You will hear that a lot. And we're going to define that too. And we're going to come back around to this in just a second too. So let's define constant of proportionality. Sorry, this pen is horrible. Okay, so the constant of proportionality, which is also known as K, is the value that determines whether the relationship is proportional. So it's the value that determines whether the relationship is proportional. Okay, so let's look a little bit closer at the slope and this constant of proportionality. Because they both have the y and the x. So slope is the change in y over the change in x. Right? So it's a comparison of 2 points. And the comparison of those 2 points give us the pattern of our line. So comparison of 2 points, that gives the pattern of the line. That says pattern. The K, or constant of proportionality, is just y over x. So it's a ratio created from an ordered pair. Now, the slope gives the pattern of the line. This does as well. The constant of proportionality gives us the pattern of a proportional relationship. So this gives the pattern of a line that is proportional. And that's what we're going to be looking at today, is deciding, how do we even know that? Like, how do I know that that's proportional? And what we're going to see happen over the course of the next few lessons, every single line has a slope. Okay, every line has a slope, whether it's, vertical obviously doesn't, but the lines that we're looking at are going to have a slope, whether they're proportionate or not. Okay, so a proportional relationship line has a slope, a non-proportional line has a slope. If our line happens to be proportional, we call the slope constant of proportionality. It's kind of like rectangle square. Every single four-sided figure with 90-degree angles is a rectangle. Except sometimes it's also a square. Same kind of thing here. Every line has a slope. Change in y over change in x. Every straight line that we're going to be working with besides vertical. But some of them, the slope is actually the constant of proportionality. All right, so let's just start looking at some examples. This is something that makes a lot more sense as we see it happening. All right. Example 1. So we are going to look at kind of like a real situation first, and then we're going to do a bunch of examples with very basic setup so that we can see a bunch of examples. So Alberto types 15 words per minute. Okay, so Alberto types 15 words per minute. Now, on a side note, words per minute is a unit rate. So kind of keep that in the back of your head, because if you remember in 7th grade, a lot of ratios, proportions, unit rates. Okay, so all of that kind of comes back into play while we're graphing. All right, so what we're going to do is look at a table with the information for Alberto. So we have our X and our Y. X is going to represent the minutes. Y is number of words. So at 1 minute, 15 words. 2 minutes, 30. So let's fill out this table. All right, so again, we have Alberto, we have our unit rate. Here's our information. We are going to find the slope first. So change in y over change in x. Now we know this is linear. Okay, we can assume moving forward, unless you're asked to determine if it's linear or not, we can assume it's linear. So I don't have to test every single set of points. I can see that my change in y is a positive 15 and that my change in x is a positive 1. So I can see that my slope is 15. So now we're going to find the constant of proportionality. and I'm going to just start calling it K. I'm going to write it one more time just so we see the vocab, but we're going to start calling it K. Now, the constant of proportionality is y over x, and it's literally pick an ordered pair, and it's the y value over the x value. It can be any ordered pair that we have in our table. I can use the first ordered pair, the second, the third. It doesn't matter which one. I'm going to pick this one just because it doesn't already have markings on it. So I'm going to look at this ordered pair and I'm going to say, okay, y value over the x value. Well, 45 over 3 equals 15. Because my slope and my constant of proportionality are the same value, I have a proportional relationship. Okay, so write proportional relationship, slope equals K. I definitely want you to write the explanation here of why, so that moving forward you know why. Okay. Let's look at another example. So these next few examples, the question is it proportional? And we're going to have smaller sets of numbers just so that we can get a bunch of practice in. So, first step, find the slope. Okay, so on this example, write down the steps. Future examples, we're not going to need to do that, but I want you to have one good, clean example. So first, find the slope. Remember, we can assume this is linear. So my change in y is 2. My change in x is 1. Now, when you're doing this, definitely write the fraction before you simplify or write it as a whole number like this, because I want to make sure in your notes you see the ratio that's happening. So if this were a line that we drew, the slope would be 2. So then we're going to find K, or the constant of proportionality, which is y over x. So find K, which equals y over x. So I'm going to pick an ordered pair. It does not matter which one I pick. I'll pick this one just because it doesn't already have markings on it. So I'm going to write a fraction or a ratio of the y value over the x value. Y over x is 6 over 3, which equals 2. Because these two numbers are the same, I have a proportional relationship. And I know it's proportional because the slope equals the constant of proportionality. So I want to take a second as we are doing this to take a look at the graph of what this would look like. So if we plotted the points on a graph and connected the points, here's what we would see. And I'll put that back up in just a second. So this is the line that we would see if I plotted the points and graphed to make a line. All right. Now let's take a look at another example. So what I'm going to do is each example, I'm going to graph it so that you can kind of visualize the lines, and then it's going to come back at the end. Let's look at another example. Okay, so copy that table. And we're going to find the slope, and we're going to find the constant of proportionality. So do that along with me. So you don't need to write the steps like find slope, but you do need to identify what you're finding. Okay, so make sure you're identifying what you're actually doing. Okay, so no matter what ordered pairs you pick, you should get the same K. So if I picked 2 and 6, well, my Y would be 6, my X is 2, 6 over 2 is 3. So no matter which one you pick, you will be able to determine whether it's proportional or not. So because my slope and my constant of proportionality are the same, I can say these are proportional. Because the slope equals the constant of proportionality. So these are the two lines of what we just drew, or what we just, the tables we just got. So we're going to do a third one. However, based on what you see on the screen right now, I want you to start kind of thinking, what do these two lines have in common? Okay, so just start kind of thinking that. Don't write anything down or say anything. We're going to come back to that in a second. All right, so let's look at, we have 2 more examples. This next one is also going to be proportional. But now we're looking at some negatives. Okay, so this is also proportional, but now my y's have negative values. Same process. Identify the slope, identify the constant of proportionality. If they're the same, we know it's proportional. Again, definitely identify slope, identify constant of proportionality. Be very careful. Remember, with the slope, you can use that formula that we learned yesterday, or you can just identify the pattern that you see. But you do need to be careful, because when we're dealing with negatives, it's important that we say, did it increase, did it decrease, that type of thing. So what's happening here is I'm actually decreasing by 2, and the x is increasing by 1. So my slope is negative 2. Find the constant of proportionality. And then we'll decide if it's proportional. So my K, pick whichever ordered pair you want. Y over X is negative 4 over 2, which is negative 2. So yes, we know this is proportional. Slope equals my constant of proportionality. So my graph now looks like this. So these are the 3 tables that we just did. These are the lines that were created. So I want you to take a second and think, what do all of these have in common? Okay, so tell me in the chat what you think these 3 lines have in common. So they're all straight, which we know because we're dealing with linear equations, right? Or linear relationships. All of these lines are proportional, which we already knew, like I said, and they all pass through the origin, or they all cross the origin. All 3 of these are intersecting or meeting at the origin at 0, 0. That's going to be important. Okay, so let's come back to our paper, because we're going to do one more. We're going to look at what does everything look like when it's not proportional. Okay, so we're going to do one more. And this is not going to be proportional. So let's see what that looks like. All right, so copy that table down, and I want you to find the slope, and I want you to find the constant of proportionality. The slope you should get would be 2 over 1. So our slope is 2. Constant of proportionality, remember, we're just grabbing one of the ordered pairs. Now, there is no special set to grab. This isn't something where if you pick the wrong one, you're going to get the wrong answer. It doesn't matter which you pick. It's either going to be proportional or not. So if I pick this ordered pair, my y over my x is 7 over 3. These numbers are not equal to each other. So that tells me that this is not a proportional relationship. So we say non-proportional. The slope does not equal the constant of proportionality. Now, that doesn't mean there is something wrong. That doesn't mean it's bad. It doesn't mean it's not a line. It's still a line. It still has a slope. We're going to look at the graph and see what that makes the graph do. Because so far, no matter what we had happening, they were all proportional and they all went through the origin. So now the red line is this new table. I'm going to zoom in a little bit. Now the red line has 3 points, just like the others. The red line has points to the right. The red line is straight. So it is just like all the others, except it does not go through the origin. The reason it does not go through the origin is because of the constant of proportionality. Since the constant of the proportionality is not the same as the slope, my line is not proportional. My line does not go through the origin. Okay, so graph-wise, that's what it looks like. Now, for your assignment tonight, there's one last thing we need to put on your paper that is going to help you with your assignment. But what's going to happen tonight for the homework is you're going to have to decide if what you see on the screen is proportional or not. All right, so let me show you really quick. We're going to be using, I don't know if you guys have had any of your teachers use Jamboard. It's just another way, where is it? It's another way to kind of draw and sketch things on a Google assignment. And it's so weird. I keep, what we did with the tables in the notes is what you're going to do for these. Now, you're not going to have to show your work on this. You're going to just do work on your paper. But what you're going to do is you're going to give me a key. There's a marker on the left. Pick a color. And I'm going to say proportional is going to be blue. And non-proportional, let's say, is green. All right. So I'm going to go through and I'm going to look at each table. And if the table is proportional, mark it blue. If it's non, mark it green. Now for the graphs, if we're dealing with linear equations, so if you see a graph like this one on top right up here that I'm circling here, if it's not linear, we're not even considering it. You just completely ignore it. If it's linear, you decide, is this proportional or non-proportional? My line goes through the origin, so it's proportional. So I mark it blue. You'll go through and you'll mark the different boxes. There are some that are blank because there are equations we're going to talk about later. Okay. Then on the side, you're going to add a sticky note with some information. The sticky notes are right here. Okay. So just kind of play around with that. As soon as I can get it posted up, I don't know why it's not showing. Okay. So if we're looking at a table, for it to be proportional, the slope has to equal the k. Remember, slope is change in y over change in x. That's going to equal the y over x. If it's not proportional, the slope does not equal the constant of proportionality. For a graph, if the graph of the line passes through the origin, it is proportional. If it does not pass through the origin, it is not proportional. And the key here is only decide if it is linear. So when you see those curved lines, you can ignore them. So we only have to decide if a graph is proportional if it's linear, for right now at least.